Welcome to This Explainer. Okay, so have you ever stepped outside on a totally beautiful, clear day, looked straight up, and wondered something incredibly simple? Like, why exactly is the sky blue? I mean, it's one of those things we just totally take for granted, right? But what if I told you the sky isn't actually blue at all? Today, we're going to dive into a real cosmic mystery. We're putting on our detective hats to figure out the crazy physics of why our sky looks like this bright blue canvas while the rest of space is literally pitch black. By the time we wrap this up, you are going to understand the invisible science happening right over your head, and I promise you'll never look at the sky the exact same way again.
Because think about it, it's kind of this wild paradox, right? If the sun is out there shining away in the solar system, why does the sky only turn that brilliant blue once you're safely down here on Earth? If you were to hop in a rocket ship and cruise just past our planet, you'd be surrounded by complete, total darkness. So what on earth is Earth actually doing to that sunlight? Well, to solve this, we got to track down our main suspect.
Chapter 1, Sunlight's Secret Colors, Unmasking the White Light.
Right, so to really get the sky, we first have to take a super close look at sunlight itself. We usually picture sunlight as just pure white, or maybe yellowish white, but actually, white sunlight is basically a giant mix of different colors all traveling together in a tight little pack. You know, you've actually seen this secret revealed anytime a rainbow pops up after a storm. A rainbow is really just nature's way of splitting that white sunlight into all its hidden parts. Red, orange, yellow, green, blue, indigo, and violet. The whole shebang.
Now these colors, they don't just travel in a boring straight line. Every single one of them travels as a wave of energy. And the way physicists tell these colors apart is literally just by measuring the distance between those waves. We call that a wavelength. It's exactly what it sounds like, just the length of a single wave of light.
To picture this, think of light like waves rolling up on a beach. On one hand, you've got red light. Red light has a super long wavelength. Imagine it rolling in like those long, lazy, spread-out ocean waves. But then, on the other hand, we have blue and violet light. These guys have much shorter wavelengths. Think of them as short, choppy, super fast-moving waves just splashing quickly against the shore. Normally, all these long and short waves are traveling together, looking totally white, but everything goes crazy the second they hit our planet.
Chapter 2, Earth's Invisible Blanket, the Atmosphere Collision.
So Earth isn't just a bare rock hanging out in space, right? We're surrounded by this thick, invisible blanket of air, our atmosphere. And even though we can't see it, it is absolutely packed with millions of tiny molecules, mostly nitrogen and oxygen, just floating around everywhere. When that wave of white sunlight finally hits Earth, it doesn't just pass smoothly through. No way. It's a massive collision. Imagine taking a handful of tiny glass marbles and throwing them as hard as you can into a giant room filled entirely with bouncy rubber balls. What happens? Total chaos. Those marbles are going to smack into the bouncy balls and ricochet in every single direction. Sunlight crashing into our atmosphere behaves exactly like that.
And scientists actually have a fancy word for this bouncy, multi-directional chaos. They call it scattering. As the light waves hit all those gas molecules in the air, they just get deflected and bounce all over the place. But here is the absolute key to our mystery. Not all of the light waves bounce the same way.
Chapter 3, The Magic of Scattering. Why blue wins?
To figure out why the sky isn't just a giant rainbow, we got to think back to those short, choppy waves. The number 10 is our magic multiplier here. See, because blue light travels in those shorter, choppier wavelengths, it interacts way more strongly with the tiny nitrogen and oxygen molecules. In fact, blue light gets scattered about 10 times more than the longer, lazier red light waves. The red and yellow waves, they kind of just push straight on through to the ground. But the blue light gets knocked around like crazy.
I absolutely love imagining this like a massive party where someone is constantly spraying blue confetti from the ceiling. As sunlight enters the atmosphere, that blue light bounces literally everywhere, up, down, left, right. By the time you look up, no matter where you're standing, some of that scattered, ricocheting blue light is bouncing right down into your eyes. It is literally a ceiling of floating blue confetti. And that is why the whole sky looks blue.
Chapter 4, The Violet Caveat. Wait, why isn't it violet?
Now, if you're a top-tier detective, you might be thinking, wait a second, scratch that. If shorter waves scatter more, and violet waves are the absolute shortest, shouldn't our sky actually be bright purple? It's a brilliant question, and it totally stumps a lot of adults. The answer is actually this perfect combo of three things. First off, the sun doesn't shine out equal amounts of every color. It naturally makes a bit less violet than blue. Second, it's our own biology. The cells in human eyes are just way more sensitive to blue light, so we struggle to even see the violet that is there. And third, gases super high up in the atmosphere actually absorb a good chunk of the violet light before it even gets the chance to scatter down to us. So, blue takes the win.
Chapter 5. The Sunset Secret. Why the Sky Turns Red.
Okay, let's shift gears to the end of the day, because, the blue sky doesn't last forever. As evening rolls in, that blue suddenly transforms into these fiery oranges, pinks, and deep reds. So what changes? Well, at midday, the sun is directly overhead, right? The light travels straight down through a relatively short path of atmosphere. But at sunset, the sun drops super low on the horizon. To reach your eyes now, that light has to cut through a much thicker, longer slice of the atmosphere. Because the distance is so incredibly long, the blue light scatters over and over until practically all the blue confetti is completely scattered away from your line of sight. What survives that epic journey? Only the longest, strongest, laziest waves, the reds and the oranges. They just bulldoze right through to your eyes, giving us those amazing sunset colors.
Plus, our atmosphere is usually carrying some extra stuff. If there's dust, smoke, or tiny water droplets floating around in the air, they act like a bonus filter. They scatter away even more of the shorter colors, leaving behind only the absolute purest, most gorgeous red and orange wavelengths. That's really what turns a normal sunset into a totally breathtaking one.
Chapter 6. The Mystery of Black Space. Leaving the Atmosphere.
So let's solve our final mystery. What happens if we leave Earth completely? Imagine you're floating on the moon or just staring out the window of a spaceship. Out in the vacuum of space, there is no invisible blanket of air. There's no nitrogen, no oxygen molecules floating around. And no atmosphere means no scattering. Because there are no molecules acting like bouncy balls to deflect the light, the sunlight just zips straight past you. Without that scattering effect bouncing blue light into your eyes, the sky just stays completely, endlessly black. Even when the sun is blazing away right in front of you. It is such an incredible contrast.
So, it all comes down to this one brilliant chain reaction. Sunlight hides a rainbow, and Earth's atmosphere acts like this giant invisible filter, scattering those short, choppy blue waves right down into our eyes. Next time you step outside, really take a second to look up. That blue canvas isn't just a color, it's literal physics happening in real time right above your head. I really hope you enjoyed unmasking the sky with us today in this explainer. Drop a comment and let us know. What wild science mystery should we tackle next? Stay curious, keep looking up, and we'll catch you next time.